Everyone, and thank you for joining the webinar today, where we'll be going over two methods of road resurfacing and how to model them in RoadEng and optimize them in Softree Optimal. So my name is Lee, and I'm an account manager with Softree, and later I'll be passing it off to David Mills, one of our engineers, and he'll be getting into RoadEng. Just a couple housekeeping items. We do have attendees muted, but if you have questions, you're encouraged to type them into the GoToMeeting panel. They'll only be visible to us, and we'll go over them at the end. And a follow-up email will be sent with a link to the recording and info on how to get the templates that you'll see in this webinar. So keep an eye out for that. So the first design approach that we will go over is a very simple one, and that's just milling the pavement, just the top lift of the pavement, and then paving back to match existing elevations. So this is a simple approach used where the road structure is in good shape and you just want to resurface it. So it's often not modeled, but in situations where you are widening the road or have other pavement treatments, you may want to model it for consistency and to get quantities. So you can see in the cross-section below that the proposed pavement is going back right at the existing pavement elevation. And the second design approach is where it gets interesting. So this is where you would be milling the existing pavement and then paving to a designed vertical profile and crossfall. So this would be used where the road has settled or has little dips and it no longer is a uniform plane or no longer has a consistent profile. And this is tricky because it can require a number of different pavement treatments depending on the elevation difference between your design pavement and your existing pavement. And those treatments can also be dispersed all throughout your project in different areas, and so it's also pretty tricky to model. And you can see this case in the section below, which shows the design pavement elevation in yellow and the existing in black. And this would normally be a case that you would want to avoid, as the design elevation is below the existing. Here, if you tried to mill the top lift of the existing pavement, you could run into issues as the remaining existing pavement would be too thin and could be broken up and then would have to be removed before paving. So usually we try and avoid the design elevation being lower than that. So that makes the profile design tricky, as it has to be above existing, but you still want it to be as low as possible to minimize the pavement quantities and the cost of the project. So it's kind of the opposite of the Price is Right. You want to be the closest you can without going under. And so we'll be going over how to design this manually in RoadEng, and then we'll also show how you can use Softree Optimal to optimize the profile design. And just in case any of you aren't aware, Softree Optimal is an optional add-on to RoadEng that uses a patented mathematical process to optimize your design. It's usually used on cut and fill and kind of earthworks, but here we'll be applying it to fine-tune our resurfacing profile. And so with the intro out of the way, I will pass it over to David to get into the meat of the presentation.
Thank you very much, Lee.
Okay, there you go.
Okay, so I think we're looking at my screen. Is that correct, Lee?
Yep.
Good. Well, let's start up with the terrain module. I'm just going to show you what the project looks like. And I'm going to open up, well, actually, I'll just open up this one here. Oh, it's already open. Let's just bring it to the front then. Right, so here we've got a surface in the background and line work in the foreground. and the line work has been surveyed. You can see that we've got a paint line for the center line has been surveyed. The edge of the traveling lane, which is also a paint line, has been surveyed. And right out here we've got the pavement edge, and then there's a whole bunch of other brake lines and so on. The data came in LandXML format, which at least the original ground data did. I've created some contours on that, and you can see it's got well-defined elevations everywhere. But we're not going to be worrying too much about where the surface came from. Let's now take a look at designing on this surface. So I'm going to flip over to our location module and start a new alignment. As is usually the case, we start with a original ground surface. And there it is. You can also read that directly out of LandXML here, but I've already converted it into the terrain format, so that's the way I'm going. In addition, you can pick an alignment from a LandXML file. LandXML can store both alignments and surfaces. Now, I'm going to use for the, well, actually in both of my examples here, I don't need to bring in the vertical alignment, although there is one, because I'm going to design my vertical. So we're not going to take anybody else's work. We're just going to start from nothing. So we've got a horizontal, which is the surveyed alignment, or at least, well, we'll see in a second what that looks like. Let's leave the template empty for now. So the horizontal alignment has got curves in it. It's been designed to match the paint line that was surveyed. So let's look at those in the background. There's all the line work I was showing you a minute ago, and you can see that the surveyed center line, that's the dashed red line, is very close to that faint olive line there that represents the paint line. Not exact, but that's typical. Okay, so I've got a horizontal alignment, and my vertical is undefined. It's literally the ground line. So now I'm going to just do the simple treatment where I assign a template. Now I don't have the template on board yet. Let's go and get it. So I've just got the default templates here. I spent a little bit of time making some new paving templates, and I'm just going to merge those in. And these templates will be available in our e-library in the future, probably next week. They seem to be working well, and we're just going to put them in there and upload them. Okay, there we go. So this is the match existing template. Doesn't matter where the center line is, it follows the ground. This one here is where we're actually designing the crossfall and the alignment. So it does move with the alignment. And this one is used for optimizing, and I'll come back to that later. We don't need it right now. So this is the one I'm going to use. And now that I've added it to my template table, I can just go into here and assign by range. Okay. And that looks pretty good. I'm just going to distort my section window if it's not already distorted. Yeah, let's distort it by a factor of 2. There we go. And you can see how it works. Now the problem here is that I probably don't have the edge of pavement lining up with the true edge of pavement, nor the shoulder edge lining up. By the way, that notch in the milling depth is completely optional. There's 2 parameters in the template. Let's just go back there. One parameter is the pavement offset, and the other parameter is the shoulder offset. And if you set those to the same value, then there won't be a notch. It'll just be the full milling depth all the way out. Right, but I've just chosen a couple of numbers that are maybe right, but maybe not right, and especially might vary along the alignment. So how can I deal with that? We've already got these surveyed features in here, so I'm going to use them. This one is called V-Road Pavement Edge, and that one is called V-Road Marking White. And I'm going to use those as reference features to tie off the edge of my milling and overlay template. There's a couple of different places you can create reference features. I'm going to use the template options as my starting point. Okay, so I need a new reference feature. I'm going to get it from oops, wrong folder again. I'm going to get it from my surveyed line work. And it's going to be, oops, wrong browse button. Right, that's good. And then here, I'm going to browse for the actual pavement markings. Okay, so let's do the pavement edge first. There it is. So there are 16 pavement edge lines. It doesn't matter if there are multiple lines. It doesn't even matter if they're on the opposite side of the center line. Just select them all. This is going to be the thing that it looks for when I tell it to use reference feature pavement edge. Let's just call it that. And I want to see it in my cross-section window. There it is. So the pavement edges are not lined up with the template, but they will be as soon as I set the template to use that reference feature. Now I just pulled these templates in from an existing design, and in fact, if you take a look at the options here, the pavement offset is already set to use reference feature 1. So all I really need to do is recalculate. In fact, the shoulder offset is, well, it will be set to use reference feature 2 as soon as we create it. So let's do that. So you can see already in the template editor, the edge of milling is lined up with that reference feature symbol. Good. Let's add the other reference feature. And this one was V-Road Marking White. There it is. There's the first one. And there's the last one. You can use this to type in the name if you have it. There we go. 23 of them. That's correct. Okay. And again, I want to see it in my section window, so let's just turn on a symbol there. I'll use the default triangles. Great. And recalculate, and everything should be done. I basically am finished. So it's automatically calculating where the milling needs to go to. So if I look at any place on my alignment, it's lining up with those surveyed lines. The depth is determined by the template. Hopefully I've got them right, and it's not going to go too deep or yeah. cut through the old pavement. That's always a mystery. Depends how well it was laid down. And I could output the data. Let's just change screen layouts. I created one here called MO output, milling and overlay output, and it's set up to show me, first of all, some nice hatching in my cross section, and then volumes. So every 20 meters, I've printed out the surface 8 cut volume. That's my milling, and surface 12 fill volume. That's my overlay, and of course they're the same. And this volume here is the level course that would go underneath if the alignment was too high. And of course there isn't, that situation never happens when you're matching the existing surface, so that's 0. And we can go down to the bottom here and see what the total is. Oh, there's a slight difference. Oh, I can tell you why there's a slight difference, because this design gets gnarly at the other end. We probably want to truncate it. There's stuff going on over here that we've basically got some horizontal offset. Yeah, I'm just going to truncate the design here to 12,350 or 12,380 is good enough. Right. Okay, now let's look at those totals and see what we've got. So the milling and the overlay are equal, which is what you'd expect. And whatever the pavement was looking like, and you can see in this particular cross-section, there's quite a large crossfall here. In fact, it is 4% and 4%. Both sides it's 4%. So maybe the shoulder has settled a little bit. It might have ruts in it too. It depends how the survey data was taken. If it was truly just surveyed on the paint line, then of course there's just a straight line between. But if we picked up drone data or LiDAR data, it might even show the pavement ruts, but it doesn't here. Okay, so that's step one, simple. Basically all you do is apply the template, make sure it's in the right position horizontally, and you got your volumes, you've got your model that represents the mill and overlay. Now what if we wanted to change the surface and we're not willing to live with the existing pavement surface? Different template. So I'll just switch to this template, which no longer matches the surface. And you can see right away at this cross section, the crossfall is reduced to, I think it's 2%. Yeah. So we're going to have some fill at each end here, or at least the pavement will be a little higher. There probably are some cross sections that have need for a level course. Let's just see if I can find that. Oh, and here's a bad one. This is what Lee was talking about earlier. This is the situation where the designed pavement is below the existing pavement, so the effective milling depth becomes deeper than the prescribed milling depth, which is probably going to leave the pavement underneath too thin, and it may even remove it entirely. So bad news here. What should I do? Lift the alignment a little bit. We haven't designed the alignment. It's still following the ground line. So that would be the next step. I'm going to do that. What else did I want to show? If there was, well, we'll see it when I design the alignment. So let's design the alignment. Vertical intersection point, another one. I think I can get away with 3 curves here, like so, and put in some curves. Okay, let's go back here and apply a curve. We're going to be working at 100 kilometers an hour. and probably, I don't know what this one's going to be. Let's guess it at 100. Apply that. This warning is kind of a spurious warning. Let's just change that. My default template has a design speed of 60, so I'm changing it up to 100 kilometers here. Warning goes away. Good. Previous, apply, previous. Okay. Right, so that's a bit too low there. I could lift this up. That makes it good over here, but oh, it's too high in the middle. Maybe the K, maybe it needs to be a longer curve. So let's change the K up a bit. Okay, that's matching pretty close there. This one, I don't know, that looks a little better. Yeah, okay, well that looks great from a distance. But have I really made all my cross sections suitable? Here in my cross section, you can see now we've got some leveling material being added underneath because there's no milling on the outside, and there's less than full depth milling in the middle. Obviously, I'd need to add some shoulder treatment here to deal with this pavement up in the air. I'm not going to do that, but we certainly could with our software. And these numbers here are kind of telling me what's going on. It says that there is some green filling material there, level course, and the milling is much less than the pavement. Yeah, so is this a good design? Well, I'd have to check all my cross sections. Now, I'm going to jump ahead to an existing design that I've already created, and then I can show you a nice trick for testing. Okay, so let's jump ahead to, yeah, we finished doing the matching surface. I'm going to now open this design here. Which has multiple profiles already created, and this is the hand design. That's the one that's selected, current. And oh, and here's another thing I've done here. I wanted to create an alignment that's, as Lee says, above the existing template, or not template, ground, above the existing pavement, but as close to it as possible. So I've assigned a different template here. It's called Mill and Overlay Optimized. And basically, this template is just a flat line. Let's just look at it quickly. It has the same connection options, so it can tie off to those reference features. But I flattened it out, so there's no there's zero thickness for the milling and the fill on top. And it just looks like that. It's just got subgrade underneath, nothing on top. But this would be the top layer of the other template. So it matches the top layer of the actual mill and overlay template. And if it's above, I'm creating material underneath that's fill that shows me how much above I am. If it's below, I'm cutting material, and it's calculating how much I'm cutting and telling me that I'm actually below grade. So now that I've assigned that template, and I did that before I saved it, I can look here and see, is there subgrade cut? And there is. So that means that I must be below grade somewhere. There's a spot. And you can see here I'm clearly below grade. So I'd like to go into my vertical profile window here and just try and adjust it so I'm always above grade, but not too much above grade. There's a trick too we can use to find stuff this is just showing me the center line, right? What about things that are outside the center line? Turns out that the terrain module has a pretty cool feature called, well, doesn't matter what's called. We can create a cut fill surface. So if I save this surface as a terrain, I've already done this, so why isn't it in here? Oh, there it is. Oh, that's the cut fill one. Yeah, hand design TerraX. That's it. Okay, so if I turn off no, I want sections. I want the final surface. And yeah, this looks like it's correct. Okay. So this is the designed surface, and it's going to appear in my terrain. It's a ribbon of terrain. You can see it there in the 3D window. And I can use that to create the cut depth by subtracting it. And so we've got this tool, save as, regular grid, and then you got to create a regular grid. Now I might screw this up, so I'm not actually going to do that. That's this one here. Let's put a 2 on the end in case I mess up. Okay. So you choose a grid spacing, you choose what you're going to do. In this case, I want a difference between this surface and the original ground surface. And that will generate a cut fill map. I'm not going to do that. I'm just going to show you the results. So this is the difference. So the elevation is small. It goes between 0.3 and plus 0.3, minus 0.3 and plus 0.3. And then I did some shading in here. Again, I don't want to go into too much detail here because the takes a while to get everything set up. But I shaded the elevation like so. And that's what it looks like. Okay, so we can do that. What good is it? Well, when you're looking at your plan window here, you can put that in the background. So there's my cut fill. Let's turn it on. Okay. So I think that's kind of a nice output feature. When I generated this, I used 2 meter grid spacing. So that's why we get this kind of pixelated image. But you can see how it works. In the green, we're good. There's no cut. In the red, not so good. There's cut. Right. I think the main point I want to make here is that to actually adjust the profile so that it matches the existing ground while using designed curves is a tricky process. If you put in enough curves and you spend enough time at it, you will get something that's reasonable. But we can use the optimizer to do that automatically. So I'm going to now optimize this to produce my own vertical curve based on some parameters that I set. Okay, so this has already been done, but let me pretend that it hasn't. Let's just delete that. So I've got no vertical alignment on the on this one. Oops, I just deleted the wrong one. No problem. Set this one current and delete it. So here's the optimizer. This, as Lee mentioned, is an extra feature you have to pay an extra price for, but it runs with Rodench. So what I'm going to do is optimize and create a new vertical alignment, but I want to first of all set up all the options. I want the alignment to be near the existing ground. So I put in a negative value there just so that it's at least below ground. I think, I probably could have put in negative 0.1 or something because I want my alignment to always be above the ground, but I want the optimizer to have the flexibility to go below ground and a little bit above ground, which is, of course, pavement. And to start with, if you've seen the optimizer before, you know that it can generate, let's just change that to 20. It can generate back-to-back curves really quickly, but it takes a little bit longer to do curves and tangents. So I'm just going to do back-to-back curves to start with. I put in reasonable design parameters for my vertical curves. And here's the tricky part. It's already going to try and minimize cut and fill, but I actually want no cut. So how could I cause that to happen? Well, the one way that you might do that is to put in a minimum fill of 0, and that works. But another way to do it, which actually seems to work better, is to put in a borrow pit for material that you're going to need for fill. And yeah, so I've got this material available for fill, but do not put in a waste pit. So what'll happen is if it cuts, it'll try and waste material and it has no place to put it. And so it will keep lifting until there's no cut. The reason that's going to happen is because the design is set up with materials in the ground, existing pavement. That kind of makes sense. We're going to cut existing pavement if we do cut. And we're going to fill this stuff level course. It doesn't actually matter. This is kind of, it doesn't matter what it's called. It matters that it's a high quality here and that the existing pavement is a low quality and therefore it won't be able to use it for fill. Okay, so like I say, the most obvious way to get the software to optimize without any cut is to put in a minimum cut constraint. But I found that it was actually worked better to, oh yeah, and here's why. Minimum cut will give no cut at center line, but that doesn't prevent you from getting cut off to the side. So even in this situation, if I had a minimum cut constraint, this would be fine. It would say, yeah, I've got 0 cut. But in fact, off to the side of the center line, I do have some cut because I'm going below the existing pavement because of my new crossfall. Okay, so I've set up constraints that allow me to cut material if I want, but there's no place to put it. So when I do the optimization, and let's just do that, it's going to try and move that material to a non-existent pit and come out unbalanced. This is a pretty short alignment. It's about 2 kilometers long, and because I'm using quick curves, the optimization happens really fast. There, it's done. But you can see here, it found an extra 3 meters. It couldn't waste 3 meters of material, 3 cubic meters. But that's almost nothing. If I hadn't put in that constraint, it would have come out more or less balanced. So there you can see we've got quite a bit of fill and very little cut, and the alignment is tracking the ground. Now this is a bunch of curves, and I'm not saying that's the final solution, but it gives you an idea of how it would work. Now for the next 2 options, I'm not going to actually do the optimization because it takes longer. But let's take a look at the other results. So here I did virtually the same optimization, except I set the parameters slightly different. I changed the standards to use variable curves and tangents with a minimum curve length of 200 meters and a minimum tangent length of 40 meters. And that's probably all I need to say. When I did that optimization, I got this result, and you can see that it's got curves and tangents between, and it's matching the ground, and it didn't try to do that vertical curve, that crest curve with one curve. It put in 2, 3. Well, this is kind of interesting. What we've got here is, I want to lock this so you can see the numbers. Lock and zoom in. There we go. I have really large K value, and same with the curve next to it. So the optimizer is just an algorithm. It's come up with some reasonable curve K value here, 95 there, 121 there. So that curve is actually not a continuous grade, right? That's why it's hard to match with the when you're doing it manually. And then it put in these really, really long curves here, which are essentially tangents. So I can actually, if I want to, delete those. So let's just look at the numbers here, 10 and almost 1600, and then see what happens when I delete those curves. So that's one point about the optimizer. It gives you an alignment, but it doesn't prevent you from modifying it or adding curves or removing curves. And if I recalculate all, I think it did that for me automatically. Yeah, see, it didn't change much at all. So really, those curves were unnecessary. So now I've just got a couple of IPs in there with very small grade breaks. 0 in my to 1 decimal place is 0. Okay. So that's alignment number 1. I'm kind of happy with it. It's got a little bit of cut, but virtually none. And it's got this amount of fill, which is going to be, well, we'll see later how much that will turn into leveling course. But I wasn't satisfied. I thought it would be interesting to try another optimization. So I just created a new alignment. You can just right-click New and add a new vertical. And I changed the properties a little bit. So I changed the standards to reduce the length of curve, and I actually increased the accuracy by going up to high, well, level 4 here. So the base length is 10. What this means is that the alignment is chopped up into 10-meter segments, and then it builds 40-meter tangents plus, so they can be bigger, and 160-meter curves or bigger out of those 10-meter segments. So they can move around, but you'll see that all the curves will start basically on a 10-meter range. If I go up higher like this, then it makes it less flexible. Problem with more flexibility is it takes longer to calculate. Okay, so I tried a different set of parameters, and what did I get? Well, let's set that current and take a look. So it first of all put 3 curves up there instead of 2, and it put an extra curve down here, which is not stupidly large, and it came up with slightly different numbers. I think this number was significantly smaller, which means that I'm actually closer to the existing pavement. Just to give you an idea, that took 42 minutes, whereas the previous one took just under 3, and my quick curves result was very, very fast, less than a second. Okay, so the optimizer can give you a profile that matches the existing ground. Now that I'm finished with that, I just need to change the template back to my real template and generate some volumes. So I'll just do that. The template should actually be this one. And I'm going to open another screen layout to show output. So I set up a data window. What else did I do in the output? Not too much. It's basically the same as we're looking at here, but it's got a different data window. So screen layouts can really save you time. Oh, we've still got that thing in the background. Let's just get rid of that. I don't want to look at the cut fill map anymore because that's from a completely different alignment. So let's remove that. I could make a new cut fill map and it would be all much fainter green and there would be no red. So here are typical cross sections. We've got the fill leveling course underneath and the finished top layer of pavement on top. That's a typical cross section. There's another one. There's bound to be some in here that are that don't have very much fill. Yeah. And here are the total volumes. So the amount of fill material I need to go underneath the alignment is almost, or underneath the top layers is almost zero. There's a little bit there. So you can, yeah, and that's being added into this volume here. Looks a little bit less than it should be. Am I up to date? Let me just double check that. Yeah, that's up to date. Oh, I see. I'm not at the bottom. Yeah. Oh no, 1.9. Look at that. So there's 0.1 there. Yeah. Okay, 0.3 square meters. And we're looking at every 20. And the next one is okay, the numbers seem reasonable. Well, that's pretty much all I wanted to show you, and thank you for your patience. If you have any questions, now's a good time to type them in there. In summary, designing the profile by hand is hard. If you want to match the ground and only be a tiny bit above it and always be a tiny bit above it for the entire cross section, it's not easily done. After you've spent some time doing it by hand, there are feedback tools to provide information about how good you've done it, where the new cross section is below grade, where it's above grade. We can produce a cut fill map to help you with that. But the optimizer, if you set the parameters correctly, will automatically create a vertical alignment that will track, let's just turn off block scale there, that will track the ground as best it can while maintaining your design parameters, curvature, crossfall, super elevation, etc.
Okay, thanks Dave for running through that. Definitely some interesting stuff, definitely getting into the weeds of road resurfacing. I know right at the end of my time in consulting, I did this exact scenario, and it was definitely time consuming and iterative to try and come up with a design that met the criteria, but still was cost effective. And this is definitely a great case for the Optimal to save you design time and optimize your design and lower construction costs. So there's, I think we're run over time, so I think we'll leave questions. If you have any, please feel free to reply to the email follow-up you'll get. So thanks everyone for coming out, and hope you have a great rest of your day. Bye.
Bye now.